Hi everybody, welcome back. We're doing some exponent work today. Exponents, you start to see them in grade 9 and then grade 10 you get hit with them big time. So let's talk about what exponents are. First of all, some terminology. So what is that equal to? Well, it's equal to 9, okay? So what's happening here is we have this thing here which is called the base. And this number here, I know most of you know this already, but just so that we're clear on the terminology, that's your exponent. Okay, what this means is simply 3 times 3. Okay, 3 times this base times itself 2 times. This is 3 times itself 3 times, which is 27. Okay, if you have 5 squared, well, that's 25 because it's 5 times 5. Okay. One way to understand exponents is to look at it in picture format. So 3 squared, as I said, is 3 times 3, which is 9. So what does this mean? Well, we could say even 9 units squared on this. If we're talking about something like this. Okay, so what we've got is we've got 3 units, 1, 2, 3, times 1, 2, 3 units, which gives us 9 units, okay? If we're cubing, we have 3 times 3 times 3, which is 27. So imagine this, we have a cube. This is a perfect cube, like a sugar cube, okay? Okay, so here we have 3 times 3 times 3. So if you imagine that these were sugar cubes that are stacked up, how many sugar cubes do you have? Well, you have 27, right? So, and that's kind of where the ability to see this graphically ends. I mean, if you raise something to the power of 4, you can't really draw something that works that way, that we don't really have a 4th dimension. So, but this is a way of understanding how we end up with these squared and cubic units, okay? What's this equal to? What do you think? Well, what we've got actually is -4 times -4, which is positive 16. Because when we multiply 2 negatives together, we have a positive. What do you suppose that's equal to? Well, as it happens, what this really says is this. So it's equal to -16, okay? And it's a bedmass thing, right? So remember your bedmass rules say you have to do the exponents before you do the multiplication. So this exponent 2 is not raising that negative. Here it is, but here it's not because it's not in brackets. So it's only raising the 4. So that's why we've got 4 times 4, 4 times itself twice, and then we multiply by the -1 that's in front, okay? A lot of students get this wrong, and the reason they get it wrong is not because they don't know that, it's because they plug it into their calculator. They plug this into their calculator like this. They leave the brackets off and it gives them -16. It's the wrong answer, okay? How do we deal with more than one exponent on something? What is that equal to? Okay, well, the rule is that when you have one exponent raised by another exponent, you multiply those exponents. So what this says is 2 to the 6. Now 2 to the 6, if you don't know, is 64, okay? There are other ways of looking at this. So you could say, okay, well, that's the same as 2 cubed squared. Since we can multiply things in any order, it really doesn't matter what order we multiply the 2 and the 3 in, we're still going to get 6. Now you can say, well, look at that, that's 8, because 2 cubed is 8, and 8 squared is 64. This is a little bit more accessible because it's a times table number that you ought to know, okay? Remember, you want to know your squareds up to 12, your times table up to 12 times 12, and then your squareds probably even beyond that. Here's an interesting way of looking at powers of 2. So 2 times 2 times 2. Okay, is that 6? It is. Okay, so what we've got here is we've got 2 to the 6, which I said a minute ago was 64. Now these two 2's make 4, those two 2's make 4, and so do those two 2's. And so what we've got is 4 cubed, okay, which is, no surprise, 64. Another way to look at it is we could take 2 cubed, 2 times 2 times 2, and get 8. 2 cubed again, 2 times 2 times 2, and get 8. 8 times 8 gives us 8 squared, which is 64. So no matter how many ways we break this up, it's still going to be 64, okay? Let's see, what else can we do here? Okay, so some more laws of exponents. So what's a to the power of x times a to the power of y? Now, if you've done some polynomial work, you probably know this. Let's use some concrete numbers. So we have a squared times a cubed. Do you know what that is? What we do is we add the exponents. So when we're multiplying the bases, we add those exponents, okay? So it would be, this would be a to the x plus y. That's the rule, okay? If we're dividing bases, we subtract the exponents, okay? So if we've got 2 to the power of 6 divided by 2 to the power of 3. So this goes back to the last example. You can play around with this to understand it better. So 2 to the 6 is 64, and 2 to the 3 is 8, right? 64 divided by 8 is 8. Now another way to do it is to simplify those exponents. So remember, we subtract, so the 6 minus the 3 is going to give us 3, isn't it? And what's 2 cubed? Well, it's 8. So we end up with the same answer, right? Okay. So if we're dividing the same base and the bases have exponents, so let's do this one. That, okay? Well, what this is equal to is 5 to the power of 3, because we have 5 to the power of 4 divided by 5 to the power of 1, which is 5 to the power of 3. So we go 4 minus 1, okay? Here's how you can look at that. You can say, okay, this is what I've got on top, and that's what I've got on the bottom. And then those just cancel out. That's why we can subtract them, okay? That's why that works. Now I'll just quickly touch on negative exponents because they give everybody grief, and we're going to be doing a lot more of these in the future. So if you have a negative exponent, like that, we don't like negative exponents, okay? They're really hard to work with. So what we do is we make them positive, and here's how we do it. We take the base. Now this base is a over 1, okay? It's helpful to think about the 1 being there. Usually you don't need to do that, but when you're doing this, you kind of need to know that. And what we do is reciprocate that base, and now that a has a positive exponent too. Now, the 1 has a positive exponent too as well, but we don't write that, okay? You could write 1 over a all squared, but it's typically not done, okay? We're starting off with an integer, and because of that, we end up with a 1 on top when we flip. Now 1 to any power is always 1. 1 to the power of 67 million is still 1. 1 to the power of negative 32 is still 1. It doesn't matter what you raise 1 to, it'll always be 1. So that's why we don't bother writing the squared on the 1, we just write it on the number that actually will change. So to see an example of this, 5 to the negative 2 is equal to 1 over 5 squared, which is 1 over 25. Okay, so that's how that works. So we'll do lots more of this in the future. That was just a quick introduction. If you liked the video, please give me a thumbs up and subscribe to the channel, and we'll see you next time. Thanks.